Okay, so in this example, find the radius of a cone given the surface area and the slant height. Round to the nearest tenth. So T, by the way, sometimes is used in your book as meaning total surface area. And L, we already know that's supposed to be an L right there, means slant height. Slant height. So we know surface area equals pi times radius times slant height plus pi times radius squared. So we have pi times, okay, we don't know our radius. That's what we're solving for. But we do know our slant height is 15. It told us that right here. And then pi times radius squared. Again, we don't know what that is. But we do know that all of this equals our total surface area of 359. So again, this is one of those where I'm noticing right off the bat that I have a pi here and a pi here. And so if I divide everything by pi, that makes these guys cancel out. And that gives me, remember we're going to use all the decimal places, 114.2732 ... equals 15r plus r squared. Lucky us, it is indeed quadratic, friends. And so, also lucky us, this is not going to factor nicely. So if we're not going to factor, really our other options are completing the square or the quadratic formula. So at this point in the year, you actually have the quadratic formula program in your calculator. If you go to PRGM, oh, I don't have it on this calculator. Okay, so actually, now that I think about it, several of you may not have the program on your calculator anymore if your battery's died or something. So we'll do this the long way, and then if you have the program, you're welcome to use it. So let's remember what the quadratic formula even is. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. And this is what you use to solve a quadratic when it won't factor. This is kind of the go-to strategy. Not the only, but the go-to. So the idea here is we put this in standard form. We're going to flip around the order here. We're going to put the r squared first. Then I'm going to put the 15r. So those guys just switched order, no big deal. And then I'm also going to make this 0, which means I had to have subtracted the 114.27 from both sides. So this is minus 114.27. Okay, and so if this is in standard form, ax squared plus bx plus c, then our a would be a coefficient of 1. It's whatever your coefficients of those are, that's the number. So b would be 15, that's the number in front of r, and c would be the 114.27. Okay, so a we said was 1, b would be 15, and c is negative 114.27. So what we do is we put that in the quadratic formula. So x equals negative 15, negative b, plus or minus the square root of 15 b squared minus 4 times a, which is 1, times c, which is negative 114.27, all over 2a, 2 times 1. Okay, so then from there, it's really just a matter of following the order of operations. So we know 15 squared is going to be 225. So I'm going to make this x equals negative 15 plus or minus 225 minus 4 times 1 times that 114. And I'm copying and pasting that with all the decimals. So that ends up being a negative, and a negative would be a plus 457.09 all over 2. Then again, order of operations would say do what's underneath the square root first. So that gives us 682.09. And then remember from there, you split this into two possibilities. This plus or minus right here means there's two scenarios going on that we've just been combining into one scenario. But really, one scenario is negative 15 plus the square root of 682, and the other scenario over 2, and the other one is negative 15 minus the square root of 682.09. Okay, and so if we put those in our calculator, the first one gives me approximately 20.6. That's not right. I goofed. I didn't count for negative 15. Okay, the first one gives me 5.6, 5.55. And the second one gives me negative 20.6. And so since this one's negative, that's not an option. Our radius would have to be approximately 5.6. So that's pretty intense. It's good for you guys to review how to do the quadratic formula because you haven't maybe done that in a while. But I highly doubt I'll have anything like that on our next quiz. And then example 4, we're going to actually hold off on example 4 till we're going to have a whole lesson just on composite figures. So that's it for today's notes.